Good afternoon, dear students. Today we have to start BSc third sem. BSc third semester. In BSc third sem, DSC. DSc paper. DSc paper. Third, you consider first DSc first. D means discipline. S means specific core course. In BSc third semester, I am going to start second unit. Unit second, phase equilibrium. Phase equilibrium. Here, phase equilibrium. First, what is meant by phase and what is meant by equilibrium? First, you are going to this phase equilibrium and basic terms. What is meant by equilibrium? Equilibrium or chemical equilibrium. Remember first some points. First, in equilibrium is that is many chemical reactions do not go to completion. Many chemical reactions do not go to completion. Instead, but attain a state of chemical equilibrium. Many first point. Many chemical reactions. Many chemical reactions. Many chemical reactions do not go completion. Many chemical reactions do not go completion. Instead to attain a state of chemical equilibrium. State of chemical equilibrium. This is the first point. Many chemical reactions do not go completion, but instead of to attain a state of chemical equilibrium. Physically and chemically equilibrium. It takes place. A reaction is equilibrium. Second point. Equilibrium is the process. Equilibrium is a process in which the conditions such as concentration, temperature, pressure. Equilibrium is the process in which the conditions like such as concentration, temperature, pressure do not show any change with a time. Pressure of the system do not change with the time. Do not change with the time. Third point, chemical in all equilibrium in all processes attain equilibrium. In the all processes, equilibrium is a process. In the all processes attain equilibrium. In all processes attain equilibrium. In all processes attain equilibrium. Two opposing processes are involved. In this, two opposing processes are involved. Processes are involved. Here, third point, in the all processes attain equilibrium. When equilibrium is attained, two opposing processes are involved in that chemical reaction. Fourth point, equilibrium is attained. When equilibrium is attained, when equilibrium is attained, when equilibrium is attained, the rate of the chemical reaction and equilibrium is attained, the rate of these two opposing processes, two opposing processes are equal. Here, these are the 4 points for equilibrium to understand equilibrium. First point is the many chemical reactions do not go completion, but instead to attain a state of chemical equilibrium. This equilibrium is the processes which the conditions are such as like concentration, temperature, pressure, the system do not change with the time. In a particular time, do not change with the particular in any time. Third point, in the all processes attain equilibrium. In all processes, when the equilibrium is attained, two opposing processes are involved. And here, when equilibrium is attained, the rate of two opposing processes are equal. I told that there are two opposing processes. What are those two opposing processes? Two opposing processes, two types. One is a physical equilibrium. Physical equilibrium. Second one is chemical equilibrium. Chemical equilibrium. In this physical equilibrium, if opposing processes involve physically changes, That is a physically change. That equilibrium is known as a physical equilibrium. Physical equilibrium means here the opposing processes. That is two opposing processes, physical equilibrium and another is a chemical equilibrium. First one, it involving physical changes. That equilibrium is known as physical equilibrium, and the opposing process involve the chemical reactions. The equilibrium is known as a chemical equilibrium. Next, another point, chemical equilibrium. Main definition of chemical equilibrium. What is meant by chemical equilibrium? Chemical equilibrium is defined as a state in which the rate of forward and reverse reactions are equal. Here, chemical equilibrium is the chemical equilibrium is defined as the rate of forward and reverse reaction. The state of forward and reverse reactions are equal. And the reactant and the concentration of reactant and products are constant. And concentration of reactant, the concentration of reactant and products remains constant. Remains constant. Here, chemical equilibrium is defined as the state in which the rate of forward and reverse. The state in which chemical equilibrium, the state in which the rate of forward and reverse reaction. This is a forward and this is a reverse reaction. Forward and reverse reactions are equal and the concentration of the reactant and products are remains constant. This is known as the definition for chemical equilibrium. Chemical equilibrium is I have 100 rupees. You have to understand. I have 100 rupees. You have 100 rupees. You given to me 100. Sorry, 50 rupees. Consider 50 rupees. I given you 50 rupees. There is you have 100 rupees and this I have 100 rupees. You have 100 rupees and suddenly stops this process. Suddenly stop this process. They attain that reaction is known as a chemical equilibrium. I hope you understand this concept, chemical equilibrium. This is a basic. This is the basic concept of in phase equilibrium. Next, we are going that is a phase equilibrium. That what is meant by phase equilibrium? This phase equilibrium. Phase equilibrium. I have written in short phase equilibrium. The study of the equilibrium which exists between the study of equilibrium, the study of equilibrium which exists between or within different within different state of matter. Matter such as solid or namely solid, liquid, gases. Here, the phase equilibrium is defined as the study of equilibrium which exists between or within different state of matter. Different state of matter. One is a solid, another is a liquid. This is a different state. That is a different states of matter, such as solid, liquid, gases. This is known as phase equilibrium. In phase equilibrium, you have to understand another concept: homogeneous and heterogeneous. Already studied in PUC homogeneous first PUC, that is solution in homogeneous and heterogeneous. Another concept, homogeneous. The homogeneous, here homogeneous, the homo indicates the prefix, this homo indicates sameness. Homo indicates sameness, and heterogeneous, another is a heterogeneous. Here heterogeneous, the prefix hetero means different. Hetero means different. Define homogeneous. Homogeneous is defined as the one whose chemical composition and physical properties are same in all parts of the system. Definition of this homogeneous system. This is a basic. I can't write in the board. The homogeneous system is defined as the one whose chemical composition and physical properties are same in all parts of the system, or it is continuously from one point to another. This is known as homogeneous solution. In homogeneous, for example, homogeneous, take homo, that is oxygen, gases like hydrogen, oxygen, nitrogen. These are considered homogeneous. In atmosphere, present hydrogen, oxygen, nitrogen. These are mixed. You have to not visible to naked eye. This is mixed gases. That is the homogeneous. It is not seen as naked eye. It is not visible. This is known as a. These are the example for a homogeneous system. Next, heterogeneous system. The prefix hetero means it indicates different or difference. A heterogeneous system or mixture consists of visibly different substances or phases. Visibly different substances or phases. Different substances or phases means that is solid, liquid, gaseous, and here you take liquids, that is oil in water. Oil in water. In heterogeneous, you form a two layer. You have to take a beaker, you add water and oil. In this beaker, you have to layer in this two different layers from in between eye line water. In between eye line water, it form a layer that is to see visible. To see the visible to the your naked eye. That is known as a heterogeneous solution. Okay. Next, come to your chapter that is a phase equilibrium. First of all, what is meant by here phase? What is phase? The phase is a solid or liquid or any gases. Here, phase is a homogeneous. Remember, it is a 3 points. Homogeneous, chemically homogeneous. Right? Chemically homogeneous. Chemically homogeneous. Homogeneous. And another physically distinct. Physically distinct. And third point, mechanically separable from any other part of the system. Mechanically separable. Mechanically separable. Any other part of the system. Other part of the system. Other part of the system. Here, the phase is a chemically homogeneous. You have to see homogeneous, that is uniformity mixing, chemically homogeneous, physically distinct. Physically distinct means you have to see the layer wise. It is a heterogeneous. Third one, that is mechanically separable. Any other part of the system. Mechanically separable. You have to use any instrument. You separate the water and oil is mixed. You have to separate it from using separating from you. Separate it mechanically using any other instrument. Definition of this phase. The phase is defined as homogeneous. This chemically homogeneous and physically distinct any part of the system bounded by the surface and mechanically separable any part of the system is called as a phase. In your examination, 1 marks, it is very important. 1 marks. This is the phase is defined as homogeneous, physically distinct part of a system, physically distinct part of a system which is bounded by surface and is mechanically separable from other part of the system, mechanically separable from other part of the system. This is a definition for the phase. Next comes that is phase rule. Next point, phase rule. This is what is meant by phase rule. Phase rule, you have some highlight some points. Phase rule is an important tool. Phase rule is an important tool dealing with the study of heterogeneous behavior of heterogeneous system. This is a phase rule is an important tool dealing with the study of behavior of heterogeneous system. First point, Phase rule is a important rule. Phase rule is a important rule dealing with the study of dealing with the study of behavior of dealing with the study of behavior of heterogeneous system. Heterogeneous system. The phase equilibrium depending upon this heterogeneous system. We are using here the heterogeneous solution. The phase rule is an important tool dealing with the study of behavior of heterogeneous system. We know already that is what is meant by heterogeneous. And second point, this phase rule an important the phase rule an important generalization equation is given by scientist Gibbs. An important generalization an important generalization given by J.W. Gibbs. J.W. Gibbs in 1876. 1876. In phase rule, the mathematical equation, the J.W. Gibbs is the American physicist given J.W. Gibbs in 1876. An important mathematical generalization gives one formula, that is F is equals to C minus P plus 2. This is a very important. In your examination, you are asked 1 marks. 1 marks question. Write the generalization equation of Gibbs phase rule equation. This is known as the Gibbs phase rule equation. Here, F is a degree of freedom. This where F is degree of freedom. F is known as a degree of freedom, and C is known as a component. I have written here. Phase rule equation. Phase rule equation. F is equals to C minus P plus 2. This is very important for 1 marks. Where F is degree of freedom. Degree of freedom. F is degree of freedom. C is number of, here you have to write number of degree of freedom. Number of components. Number of components. C is the number of components. And P is number of phases. Number of phases. And these are the variables, that is the temperature, pressure. Here F is the degree of freedom and C is the number of components and P is the number of phases. You know already phase. What is meant by phase? That is, phase is a chemically homogeneous, physically distinct and another mechanically separable from other part of the system. You have how to calculate the phases. How to calculate phases. Here, this is a phase rule. First point is it is the behavior of the study of behavior of heterogeneous system. Second is given phase rule, and third point here the phase rule. It is using this phase rule. It is possible to predict the qualitative effect of temperature, pressure, and concentration in a heterogeneous system in equilibrium. The effect of it is possible when this studied phase rule. This is why we study. It is a prediction of or predict the effect of temperature, pressure, and concentration. Effect of temperature, pressure, and concentration in the qualitatively. That is qualitatively temperature, pressure, concentration in a heterogeneous system in an equilibrium. This is helpful for the finding the components, finding the phases, and finding the degree of freedom. Next, that is and next study that is the next concept. How to calculate phase? How to calculate phases? How to calculate phases? You know, phases are a state of a matter. Matter is a solid, liquid, gases. In this phase, that is an example, the various examples. This is the first one is a mixture of gases. First one is mixture of gases. Mixture of gases, I can already that is example O2, oxygen, nitrogen, hydrogen. This whole gas, these are polar gases. The gaseous system. Gaseous state, here only one phase system. You mixed, you cannot see the visible. You cannot see visible because of here P is equals to 1. Phases are here 1. When, if here, if consider A is one gaseous atom and B is another gaseous atom. Sometimes it gives two phases. Phase is 2. Why here? You take a container. Here A is one gaseous atom and B is another gaseous atom. Or you have to take these are the atoms, or these are the elements. This oxygen, this is oxygen, this is nitrogen is the gaseous, hydrogen is the gaseous. You have to take A and here B. These two are intermolecular of attraction. When any one of the gaseous atom increases the van der Waals forces, and increases van der Waals forces, it get the liquid is converted. The gaseous is converted into liquid drops. Then it is one is gaseous and another is a liquid. Here two phases, that is B is equals to 2. Here A is greater than B. Any gas you have to consider B is greater than. Here the van der Waals force of van der Waals forces increases. A is greater than B. Van der Waals force are A greater than B, and when gas is started to the liquid, the vapors, formation of vapors. These are the liquids and formation here liquids. It is van der Waals force increases, the gaseous state is phases is equals to 2. There is no van der Waals force, that is a mixture of gases. P is equals to 1. Any part of the system, it is referred as one phase system. The mixture of gases, in a pure mixture of gases, it is referred as a single phase system or one phase system. And another example, that is second example, true solutions. True solutions. True solution, that is a homogeneous solution. Here, when in true solution, when particle size is less than 1 nanometer, that considered as a homogeneous. Less than 1 nanometer. The particle size is less than 1 nanometer. They consider a homogeneous. When homogeneous, that is a phase is 1. That is P is equals to 1. Any homogeneous system, that is P is equals to 1. The homogeneous system, the homogeneous system is equals to 1. It is referred as one phase system. Next, another example, third one, that is a miscible liquids. Third one, miscible liquids. Miscible liquid, that is a homogeneous. You mix polar. Here we take a polar, that is a H2 and alcohol. H2 is a polar and ethanol. Alcohol, that is a high dielectric constant. Here these two dipole moment. Here this is considered polar and this is the polar. You mix these two solutions, these two liquids, and it gets a homogeneous solution. That is a miscible liquids. That is liquids. Here the phase is, you can't see a layers in this solution because here P is equals to 1. Phases are 1. Next, another point, another example. Here polar, non-polar plus non-polar plus non-polar. Here polar, non-polar plus non-polar plus non-polar. Non-polar, that is the example CCl4 plus diethyl ether C2H5O C2H5. This is a non-polar and this is also non-polar, and mixed these two solutions and these two liquids mixed in one beaker, completely miscible liquid. These are the miscible liquids. When you mix polar plus non-polar, here also phase P is equals to 1. You can't see the in non-polar. You can't see any layer. It is not a separate. Here polar plus non-polar. Polar plus non-polar. Example water. This is a polar. Example water plus CCl4. Example CaCl4. Here you get this is the water and this is the carbon tetrafluoride. You mix it in a beaker, you get a two layers. You see in a naked eye. It is a visible. That is here P's phases are two. These are the non-miscible solution, non-miscible liquids. These are the miscible liquids and these are the miscible liquids and this polar plus non-polar are the non-miscible or immiscible. Immiscible. Polar and non-polar are immiscible and polar are miscible and non-polar are miscible. Here phase is one and here phase is one and here polar plus non-polar phase is equals to 2. It is known as it is referred as one phase. This is referred as two phase system. Then here I take another example in solids also. I take another example, that is a mixture of solids. Mixture of solids. Mixture of solids. For example, here the mixture of solids is hetero. Hetero is difference. It is visible to naked eye. Here you take any copper plus zinc. In B, you take a beaker, you mix it here copper and plus zinc. This is a separate and this is a separate. You are mixing uniformly and you see copper is separated and zinc is separated. Here phase is 2. That is a heterogeneous. Uniformly mixing, that is a heterogeneous. This is a two-phase system. Solid, this is a solid, this is a solid. You get a phases is 2. For example, you mix paddy and another sugar. Paddy is separated and sugar is separated. You are mixing uniformly, but these are heterogeneous. You are seeing it is a separated. That is mechanically separated. Here, jowar plus paddy. This is where rice is paddy, and here these are the solids and these are the solids, and mixed you have to see in the separates. Here that is P is equals to 2. This is referred as two-phase system. This is referred as two-phase system. I take another example, alloy. I take this is copper plus zinc. Copper, zinc when heated you mix it form a alloy. Copper and zinc mixed and do not visible to the naked eye, and here the phase is 1. The single phase, it is referred as one phase system. This is referred as one phase system. And I take another example. Another example, that is a calcium carbonate, solid calcium carbonate, and its reversible reaction, that is form a calcium oxide. Calcium oxide. This is a solid plus here CO2 gas. calcium carbonate is a solid, calcium oxide is a solid, and carbon dioxide is a gases. Here two are solids. Here number of phases are how many? That is a phases is equals to, that is a here one is solid and this another is solid and this is a gaseous. Here phase is, that is a three phases. You mix it here, that is a CaO is different and CO2 is different. Here this is a gaseous, this is a gaseous, this is a solid, and this is a solid. Here P is equals to 3. This is referred as three-phase system. You see here, the calcium is in red color. You see it is hydrogenous, and another CaCO. This is also in, this is in blue color. And you are finding this is a calcium oxide, this is a calcium carbonate, and this is gases is here, this gas, the vapors of forms here, that is this is here CO, gaseous system, and this is one phase, this is one phase, and this is one phase. Total three phase system. Here these are the examples, and hydrated solutions. Another example, hydrated solution. In a particular hydrated solution, each hydrated solutions are a particular phases, the presence of particular phases. You have to take copper sulfate 5H2 plus copper sulfate 3H2 and copper sulfate S2. This is a separate, each has separate phases. This is one phase, this is one phase, and this is one phase. Total P is equals to 3 here. The phase here, the phase is referred as a three phase. The system is referred three phase system here. P is equals to 3. And next, I hope all of you understood that is a phase. Next is a component. Component. This is I discuss next class. Until then, see the video and write in your notebook. Do work hard, guys. Thank you. Thank you so much.